What's the latest? What's going on in hydraulic fracturing today? Karen, you're thrice chairperson of the SPE Hydraulic Fracturing Conference. What are some developments that are going to be some highlights?
Well, the biggest highlights that we've seen with this shale revolution is we have a much better understanding of how the shales are fracturing. We're getting better software modeling tools to model so we can optimize these fractures and know how much water, how much proppant we should be pumping. Their downhole tools have just been revolutionary. Yes, we've been doing horizontal wells. Mobil did, I would say, some of the first commercial horizontal wells back in '94 in the Parks Devonian. But back then, we didn't have the downhole tools for isolation between all the different fracs that we were placing, and we were trying to treat a 4,000-foot horizontal well in one go.
Okay.
They call them sprinkle fracs now, when they look on the previous papers.
Sprinkle that.
Sprinkle fracs.
Sprinkle frac.
Now we have, plugs, we have sliding sleeves that we can automatically just go from zone to zone to zone. We have fiber optic, which is sort of a hot topic right now, putting fiber optic in the lateral so you can see exactly where your fluid and your sand is leaving and your fractures are generating. And then you can also watch the flow back and see where the production's coming from. So we can, make sure that if we're going to drill a 4,000, 5,000 foot lateral, we want to make the most of it and make sure all of it's producing. The other thing we're seeing is new proppants coming out. Primarily we use slick water, just basically water for fracking. The one thing that it's not very good at is carrying proppant, right?
Yeah, because it's slick.
It's slick, sand will just fall out. So one of the things that we're seeing is new proppants that will go further and it'll be more efficient with water.
Okay, what kind of proppants might those be?
Last conference, we saw one that was in the shape of an X, for example. So now they're doing sort of a extrusion molding type manufacturing of proppants. There's other proppants that they're now coating with a gel so that the gel expands when it hits water, so it keeps it sort of floating.
Okay.
It goes deeper in their fracture. They have some proppants, it's a liquid. Did you see that one?
Mm-hmm.
It's a liquid, and then it solidifies into spheres, into the formation.
It's a polymerization
Yeah,
process.
it's a
It
polymer
just shrinks
process.
back and
Yeah.
forms a bead of proppant.
Yeah,
Okay, nothing harmful to leave it down there.
yeah,
No.
right.
Polyethylene
So-
or whatever.
And I think we're going to see more of that
Yeah.
coming out. So
Yeah, I think you'll definitely see a lot of technology being developed as we try to cut costs. When prices go down, and I've seen a number of these cycles, that's the time when the oil and gas industry pulls back a little bit, slows down, looks at what it's doing, and finds cheaper, better, faster ways to do things. And this is why we actually survive and survive well, is we innovate and build on those innovations. And it doesn't require a PhD. We don't have a huge amount of research centers out there. Sometimes it's the person in the field who has the idea that pushes it just that one step further and makes it work. And we have a number of developments, shale is one of them, that we worked on for years. For instance, George Mitchell and Mitchell Energy in the Barnett Shale started drilling wells in 1981 and did not hit a commercial Barnett shale gas well, commercial-wise, until 1999, when one little piece that we all were missing fell into place, and then it took off. So it's that innovation, it's the recognition, but it's all of the inventors and the innovators out there really coming together at the conferences like the one that Karen is chairing, and sometimes it's just shop talk that gets that breakthrough.
Absolutely. Well, George, begs the question, I've got to ask, what was the one little bit that made Mr. Mitchell's efforts for 18 years finally succeed?
It was very interesting, and I went back and researched this and wrote about 30 years of the history that we've done in shales and published that in 2010 with Society of Petroleum Engineers. But this one little piece, they had tried horizontal wells, they had tried fractures of every type, with gel fractures at cross link. They had tried slick water. They had tried gas fracs. And everything had not really generated it, but what they were missing is we've always fractured at about 15 to 20 barrels per minute. And Nick Steinsberger, one of George Mitchell's engineers, one day said, you know, what happened if we go to 60 or 70 or 80 barrels a minute? And as soon as they did that, they got the first commercial shale gas well, and it took off from there. And if you look at the performance of the wells, it goes flat from about 1980s through about 1999, and all of a sudden it just goes vertical.
Wow, incredible. Just took that one thing.
One little piece.
And that was the same thing in the Parks Devonian with Mobile in '94. It was a thin, wasn't a shale, it was a very hard limestone. So horizontals and fracking work in more than just shale
Okay,
horizons.
Good, yep, good point.
And
Very
one of the big winners on that was, yes, we drilled horizontal. At the time, we did open slotted liners in it because we didn't have all the plugs back then. But we pumped at 100 barrels a minute back in 1994. We pumped those and they were acid jobs, 28% acid, and then we alternated with gel for diversion, and we took vertical wells that would make 500,000 a day to 8 million a day gas wells.
Wow, it's incredible.
So, and it was really the combination. You know, if we just did acid fracs or regular fracs, sand fracs, and all that in a vertical well, they were bad wells. I used to always go, oh my gosh, do I really have to go complete to that horizon? You know, West Texas is known for having all these multiple horizons, just stacked horizons. So there's still a wealth of opportunity.
Horizons
just
being
the pay intervals,
the pay zones, yes.
yeah, the different strata that are, you know, holding
Hydrocarbon bearing.
hydrocarbon
Right.
bearing. And they could either be sandstones, limestones, cherts, shales,
Chalks.
chalks.
Hmm.
Yeah, I mean, they're doing horizontals even in the North Sea, like we're doing in.
So there is some offshore fracturing as well.
Oh, it's all over
It's
the
all
world.
over,
Yeah,
yeah.
we're looking at it, well, we've already done horizontal well with multiple fracs in Egypt. They're very common in Africa. We've done them in South America. Just about any place on the globe where there is oil and gas, people are looking at the horizontal wells. They reduce the footprint, they reduce the cost, they give you more access
Yeah.
to the reserves that are out there. And in doing so, basically, and I can say just in the U.S. alone, that we have an easy, very conservative estimate of over 100 years of natural gas, and that's not really touching the projects that go to the next level beyond that. And there are
Yeah, there are.
definitely levels that you can go to when we need those reserves. They're here. So what we're working with right now is how do we produce with minimum emissions? How do we transport with minimum emissions? And then what is the very best way to use those produced products? And they become so cheap in the United States that we have manufacturers who moved overseas 10, 15, 20 years ago. They're coming back to the U.S. because the raw products and the energy are so cheap here. And there's literally been thousands of jobs move in along the Gulf Coast as this revolution, the shale revolution, has really taken place and progressed.
You mentioned, George, a little bit when you were talking about Mr. Mitchell, natural gas fracturing. That's something that's been talked about, maybe done. Is there a future for that, or what do you think?
It's interesting, the natural frac process, the natural gas fracturing is very, very useful in water-sensitive formations. So it's a bit of a niche product, but it is a good product. Now, if it's liquefied or in the gas phase, that depends how it's pumped and how you can carry proppant, because obviously you can't carry much proppant in a gas. But
Yeah.
we're working with technologies that will go even way beyond where we are right now with both equipment and even the techniques on how we produce these things. And I think as we go forward here, you're going to see a lot of potential for development of resources at an ever cheaper rate. You know, we have to work these things out. We have
Sure.
to find out how to do it more inexpensively. But as we've done it, the interesting thing is we become less and less dependent on foreign countries to supply us oil or gas. And so it's not the political weapon. Oil and gas are not the political weapons that they used to be. Now, they know we can produce it, we can come up to speed fairly rapidly, and we can actually meet the energy demands of this country. Now, we'll still do commercial trading all over the world, but at that same time, you took that weapon away, that blackmail weapon away, when
Now
you
they,
can
now they
produce
use it
your
the
own.
other way. Right now, they overproduce to try to collapse us.
Well,
But then it becomes, cheaper at the gas pump for everybody.
Yep. It works out for the average guy, I would say.
Yes,
And,
it does.
and in the long run, I think it'll work out for the oil and gas industry because we will take a step back, we'll reevaluate how we've been doing things, and we will innovate. And we'll come back again even better and stronger.